So, I want to attempt to answer any questions you might have about blockchain technology that are related to the technical side. Meaning, how does this stuff all work, truly? We like to get excited about the exotic locations we see these networks, and everybody loves a good price rally, right? But in all of that, it's easy to forget the fundamentals. And that's what I really want to draw your attention to with this PDF here, what I call Blockchain Basics for 2025. I know my title in game is superb, but there will be a PDF attached to this. It's linked under the video, so that way you can download it. There will be a little fee, just forewarn you, but I feel like I'm reaching a point in my career where I need to add a little bit of value to my time, if you know what I mean. But with that, you'll get this easy to use PDF that you can take with you. And what you're going to have in it is a little bit of history of blockchain technology, nothing too serious. I'm going to introduce you to a gentleman by the name of David Chong. Now, back in 1982, he wrote a paper called, and this is going to be a mouthful, Computer Systems Established, Maintained, and Trusted by Mutually Suspicious Groups. Right? But I put this in here because experts agree that Satoshi got a lot of his information and inspiration from Sham's work. Sham was also related to a project called DigiCash. I believe, yeah, he was the creator of DigiCash due to a lot of political snowstorm, for lack of better terms. That project didn't really get as far as it should have. And then, funnily enough, within a decade, here comes Bitcoin. Not to draw that type of connection, but I feel like understanding Sham's work, being aware of his work and the Satoshi white paper gives you the fullest perspective, because back then it also lends more to the cypherpunk era. And the cypherpunk era, from what I've seen after being in space for so long, lends more towards the philosophy, the attitude that we see in the space, the attitudes around decentralization and going against the banks and open access. Those things kind of started back then. So I felt it was important to add. And in the PDF, you'll notice that we have a breakdown of how they were the same and how they were different. They both mention decentralization, systems that operate without a central authority, heavy use of cryptographic techniques to ensure security and privacy. Bitcoin relies heavily on that SHA 256 algorithm, which is not only responsible for the mining, I believe it applies to security as well. Now, if you want to go down another rabbit hole, you could look into the associations between the US government and SHA 256. That's mind blowing. But that actually came in a little bit after 1982. So there's that. They also mention, while not explicitly calling it blockchain, a concept of a shared distributed record of transactions. So there's that. And again, the focus on privacy. Both systems aim to enhance users' privacy. Sham's work emphasized privacy preserving techniques, and Bitcoin allows users to transact anonymously, which we know, enhancing financial privacy. But the key differences are truly where things really begin to open up and separates Bitcoin's blockchain from traditional blockchain. That's through consensus mechanisms like a proof of work, and later detailed in the PDF proof of stake, as well as the concept of a digital currency. Like we mentioned though, Sham was involved with the DigiCash concept, but it was more so of a transaction layer, a payments interface for electronic currencies. They didn't have a flagship currency to operate the network like the case for Bitcoin. So, when it comes to the history of blockchain, you bring that fact up at the dinner table, it makes you seem a bit more cooler, in my opinion, right? But let's get a little bit more technical. And again, I did my best to make this as easy to understand as possible. You can look at blockchain like a huge notebook where everyone can see what's written, but no one can change it. You can also add to it as well. That's the piece that's missing in that analogy. But essentially, that's what it is. It's a giant ledger. It's a huge electronic ledger that's immutable, meaning it's permanent. So, the information that was recorded in the Genesis block for blockchain on January 3rd, 2009 is still accessible today, December 11th, 2024. That information has not changed and it never will. It'll be able to be accessed in 2044 and 64. And that is what a lot of people see as the true gem to what blockchain technology offers, is that permanence. It's that ability to not just trust, but verify information, items, assets, things like that. We won't, it leads to the ability to tokenize. And after you study this PDF, you'll really get a good understanding of how blockchains are able to tokenize and truly what the definition of it is, because all it really does is define the process of taking something in the real world and putting it on a blockchain. That's the term that they use for it. But essentially, that's what it is. It's like a chain of pages. Everybody has a copy. When people add something to it, it's displayed for everyone to see. That's what a block explorer is. That's the sharing with everyone. And with that record being immutable and permanent, everyone can verify it. And if that information does not line up with previous history, then it's not allowed in the book. It doesn't get access because not everyone is in consensus. So after that, we go into a little bit of explaining how, according to the white paper, Bitcoin makes use of blockchain technology to create a peer-to-peer network using a distributed timestamp server. This is what creates the no central authority, timestamping transactions, the transactions which are then grouped into blocks linked into chronological order. That is where the term essentially comes from. And then the consensus method, proof of work, that Bitcoin uses to prevent fraud like double spending. The network uses a proof of work system. This involves computers solving complex mathematical problems to add new blocks to the chain. This process requires significant computing power, making it difficult to manipulate the system. So we're going to go into more in depth on proof of work, and you'll get an understanding of how they're really different, right? And you can also discover, I'm going to pull this up here, because when it comes to the taxonomy, another term for you, taxonomy of our cryptos, I like to go to Crypto Slate, and I like to look up proof of work. Not proof of works, that doesn't make any sense. Google has been tripping with this Cloudflare stuff. I'm just not even gonna deal with it. Have y'all had that issue too? It's really making me want to switch to Microsoft Edge. Let me see. I'm trying to get a list of proof of work blockchains. Should have had that prepared. Usually easier to find. But top proof of work coins and their prices, courtesy of crypto.com. We can always rely on crypto.com, right? But you see some very popular chains: Bitcoin, Dogecoin, Litecoin, Bitcoin Cash, Ethereum Classic, some newer additions to the market, Caspa. I think that's why a lot of the OG Bitcoin guys, OG crypto people were so behind Caspa, is because it was another iteration of proof of work, maybe a better version of proof of work, better application using proof of work. Proof of work is definitely not dead, not at all, because wow, Digibyte's up 20%. But it's not dead because of the hardware. Because of the hardware, the profitability through the hardware, right? But outside of proof of work, which works by nodes compete to solve complex mathematical puzzles. The first node to solve the puzzle adds a new block to the chain. It is vastly different from its friend here, proof of stake, where nodes stake their cryptocurrency to guarantee honest behavior. The network selects or elects, in the case of delegated proof of stake, validators to add blocks to the chain based on the amount of cryptocurrency they have staked. Delegated proof of stake is a lot similar. Token holders elect a subset of nodes called delegates to validate transactions and add blocks to the chain. So I'm going to pull up some proof of stake tokens. But the one thing that people don't like about proof of stake is that disproportionate control that can honestly happen when you have too many people staking the asset. Or let's just say, like, that's a huge barrier. Oh, now it wants to work. Thank you. But that some people may see that as a barrier, right, to getting involved. If you don't have enough to put away, then, you know, that leaves you left out. A case that I can think of right now is definitely the XDC network, because it takes a minimum 2 million XDC to run a master node. And you'll see numbers like that for various other chains. There's a limit to, you know, there's an entry fee basically to get involved. But it's a popular consensus mechanism. And another thing that I've observed is proof of stake projects tend to rise in value a lot quicker. That's the thing, because even though it creates a bit of an entry fee, those that can enter tend to enter in mass. So it's a very interesting situation. And then you have practical Byzantine fault tolerance. You'll see, I've seen this, in networks like Hedera. But it's a group of nodes known as validators. They agree on the order of transactions and the state of the blockchain. Use cases often used in permissioned blockchains where the number of participants is limited. Other consensus mechanisms include proof of authority, proof of burn, proof of elapsed time. That one's very new to me. Proof of authority, VeChain uses that. I've seen a number of other Web3 carbon-related projects use that. A small group of trusted nodes validate transactions. So with proof of authority, it's really you're putting your name up over everything else, name and reputation. And that gives you the permission or the authority to validate transactions on a network. On top of that, guys, blockchain is just one piece of the big distributed ledger technology pie. You have blockchains, but you also have DAGs, you have hash graphs, you have Corda, you have Tangled, you have several forms of DLT that offer different advantages over others. And that's what we break down here too. As you can see, DLT encompasses a variety of systems, with blockchain being the most well known. And we get into some key forms. Blockchain, we covered. Directed acyclic graph. IOTA makes use of that. Constellation DAG, they even put it in their name. They make use of that. Hash graph. Example, Hedera hash graph, but a unique data structure that uses gossip protocols for efficient consensus. So you have a collection of nodes kind of agreeing on the same thing at the same time. And if everybody is clear, then that passes through. That is often a lot faster and a lot more scalable than a lot of these other ones. That's the other advantage, guys. And it also should help you understand why people trip out over Hedera Hashgraph and Constellation DAG and XRP and Algorand and Stellar, because these assets are not traditional blockchains. They're not linear. They're not chain after chain after chain. Hashgraph, you have multiple nodes coming together to reach a consensus. Your directed acyclic graphs, kind of similar. network of nodes connected in a non-linear way. So there's no determining where those nodes are going to be. So lending to more decentralization, more scalability, faster transaction processing. Having this fundamental information, again, when you see it in the market, you know, like, this asset has the advantage, regardless of what the community may be saying and what the people on CoinMarketCap and these kids on Twitter with their opinions. You know, fundamentally, it's technologically sound. So if they want to work with a company or a large government institution or entity, they have the product that can technically get the job done. And that's what ultimately drives value at the end of the day. Then we get into permission ledgers and permissionless ledgers. This is something that all of these blockchains can do. All of these DLTs can do. I really want you to understand that. Permissioned and permissionless, aka public or private blockchains. And listen to the difference in use cases. With permissioned or private ledgers, the access is restricted to a specific group of participants, i.e., a consortium of banks. We've heard that before. Controlled by a central authority or governing body. So yes, this does pull in more centralized. It's definitely a more centralized situation. But the use cases include supply chain management and trade finance. So I think that's another reason why there's an asset called the XDC network. Gets a bit of a bad rep because of the centralization aspect. But when you look at the data that it needs to handle, there's a lot of sensitive information that does not need to be public. That is the benefit of a permissioned or private ledger. Permissionless ledgers, open to the public. Anyone who wants to participate, decentralized with no central authority. The biggest examples, Bitcoin and Ethereum. What I have observed recently is that now there are both public and private options of public or permissionless blockchains. They're offering both. That is why I said all of these structures, blockchains, DAGs, Hashgraph, Corda, offer both private and public access to their technology. That's especially true when you get into the discussion of layer 2 technology. Now, here in the PDF, you get a few key differences. Data structure, how data is stored and organized, linear versus non-linear, blockchain versus DAG. Consensus mechanisms, how agreement is reached on the validity of transactions. So your proof of authority versus proof of stake versus proof of work. Permissioning, who has access, public or private. Now, we don't cover everything here, clearly, because the list would be too long. But that's why I made this corresponding video, to add a bit more emphasis. You see, here's your proof of work assets. Here's your proof of stake assets. Right? But let's continue out here and talk about the one thing that we all love to talk about, utility. Also known as blockchain use cases. Blockchain technology can power a variety of consumer-facing applications, offering unique advantages like increased security, transparency, and efficiency. We have seen the world of DeFi evolve over the years. Names in that space include Ethereum, Aave, Compound, Uniswap for sure. They lead the world of decentralized exchanges. And you'll often see stablecoins littered throughout the world of finance and more recently real world assets, which is ultimately just the institutional form of DeFi. And then you got supply chain management, loyalty programs. You'll often see that in Web3. So your ticketing applications, your fan engagement websites. There's a network called Chili's that I was a huge fan of until I talked to the CEO directly and he told me we ain't touching the states until we get proper regulation. This was months before the election, months before Biden said that he was stepping down. So might need to talk to my brother again, but I digress. Chili's worked on sports fan engagement technologies. That would also fall under loyalty programs. And then you got digital identity, which is becoming a lot more popular. Blockchain games, which will never die. I cannot wait until we reach a blockchain gaming renaissance. And under the important considerations, user experience, scalability, regulation, these are factors that may get in the way of the adoption of some of the blockchain games, digital identity applications, loyalty programs, things like that. Things that we often talk about on the channel, on the main channel to the public or whatever. And then at the end here, and I was talking with my brother Dimitri about the importance of this, programming languages, because the Move programming language is what made me turn my attention to the importance of them. Like, I never thought about it, but it must have a programming language. These blockchains must be programmed by something, right? So I started to dive into the Move programming language that's highlighted here. This was the programming language that was created by the guys hired by Mark Zuckerberg to create a blockchain for Facebook. So I'm thinking, if this thing was originally designed to support a network of 2 billion plus people, and now it has made its way into the blockchain space, let's just get into why they're important before I begin to to get us excited. So programming languages are fundamental to blockchain and distributed ledger technologies. They are responsible for building foundations, core protocols. Languages like C++ build these essential blockchain protocols, including the consensus mechanisms like proof of work, proof of stake, data structures, and network communication protocols. They are also very key to smart contracts. Smart contracts are the if-then function for the blockchain. So if this happens, then this must happen. It is written in code. That is what smart contract is. You see here specialized languages like Solidity, which is often used on Ethereum, Rust for Solana, and Move for Diem. Now, Aptos, Sui, and recently announced an asset called IOTA, which we mention on the channel as often as we can, are now going to be adopting this Move programming language. That is something you really need to keep your eyes on. It also lends to developing applications. Languages like JavaScript, Python, and Go help developers create front-end interfaces and connect with blockchain backends for DeFi, supply chain management, gaming, and more. The world of Web3 runs on JavaScript and Python. Every meme coin, every meme token airdrop, every meme token's website, it's running on JavaScript and Python. Like, I'm just being honest with you. So when you really understand these fundamentals, guys, you understand that these networks ain't really that different. That is why it is even more important to pick the right one, because they're all offering the same thing with a different branding on it, with a different brand name. And those who are able to execute the fundamentals successfully the longest, that's the key there, the longest are going to be the most valuable. That's why, in my opinion, and for those who watch this a little bit after 2024 into 2025, I'm making this during a period of time right after the election, right after Donald Trump was chosen. The market rallied. We are fresh off of a 60-day rally, first time touching 100K after the election. US-based crypto networks were the first to surge, the best performers during this time. I do not see that as a coincidence. But again, programming languages, lastly, allow for innovation and experimentation. They enable developers to test new blockchain architectures, consensus mechanisms, and application models. These languages help create solutions that allow different blockchains to communicate and share data. So, within these 14 pages, sorry guys, is a solid understanding through four key components, being the history of blockchain, how it works, different variations, consensus mechanisms, programming languages which lead to utility. You'll be able to spot truly which networks are truly the ones that will survive. Because when you really get deep into the space, you'll find not all of these networks are truly taking advantage of the real potential of the technology that they're trying to get into. You'll see that. Now, if you want to pick up this PDF, again, it'll be linked down under this video. It's, again, small fee, guys. You know, I put in a lot of time to collect this information, and I feel like this is nothing if you anticipate making hundreds of thousands of dollars, if not more, because a Lambo costs a lot of money. This is nothing. So again, with that, leave any questions you might have down in the comments, anything that we may not have covered. Coming up next, we're going to dive into decentralized finance. I did see one of your comments on that. And then I plan on getting more so into the utility aspect, tokenization, real world assets, things like that, right? Because I want to answer another question that was asked in relation to XRP's status. And we'll be able to unlock that when we dive into the utility side of things. So with that, I want to thank y'all again for watching. Y'all know what time it is. If that money is digital, so is the hustle.